Okay, here is my system. 5x plus 4y equals negative 14, and then 3x plus 6y equals 6. If you will notice, like I said on the video, none of my coefficients are opposite signs. They're all for positives, which poses a problem because I need somebody to be positive and somebody to be negative. Not only that, none of them are the same as far as the digits go. I mean, I could just multiply by a negative, but it wouldn't get rid of anything. So now I have to make the decision. Do I want to get rid of my x's first, or do I want to get rid of my y's first? It's up to you. It really doesn't matter, because no matter which one you solve for first, you should still get the same values for x and y in the end result, okay? I'm going to choose to get rid of my y values just because. So in order to get rid of my y values, I need my least common multiple between 4 and 6. So thinking about that pool, if 4 and 6 are on the outside of that pool and they're going to dive in, what is the smallest number that they can divide into evenly, that they can dive into that pool and it'd be an even number of times? That's right. It would be the awesome number of 12. So 4 can jump into that 12 3 times. 6 can jump into that 12 2 times, all right? And it's the smallest one. You might say, well, why not 24? 24 would work, absolutely. The only difference is you're going to have big numbers over here. And we hate big numbers. So let's just deal with little numbers and do 12, okay? Now, not only do I have to say, okay, I'm going to have to actually multiply both equations by something. To give me a 12 here in this y spot, I need to multiply by 3. To give me a 12 here, I need to multiply by 2. Now, is that going to give me everything that I need? I need them to be opposites of each other. It's not. One of these has to become a negative. Does it matter which one you make negative? Nope. Doesn't matter. So if you want to say, oh, well, let's make that negative. Just because the numbers are smaller. 6 is smaller than 14. Just roll with that. So I'm going to distribute 3 times all of this at the top. So when I do that, I get 15x plus 12y equals 3 times 14 is 42, and it's negative because the signs are different. Okay? Now I'm going to multiply negative 2 times all that at the bottom. So negative 2 times 3x makes negative 6x. Negative 2 times 6y makes negative 12y. Negative 2 times 6 equals negative 12. Once you make these opposites of each other, they're opposite signs, opposite values. Look, see, inverse, inverse, inverse. That way when you add them together, you get 0, which is what our goal is. So when I add these, 15 plus a negative 6 gives me 9, so that's 9x. 12 and a negative 12, go bye-bye for the time being, okay? Which is exactly the whole reason behind why I did what I did. And then I have negative 42 plus a negative 12. Since they're both negative, you just add and keep the sign. So that would give me a negative 54. And then you have one step left. Your one step left is to do division. So we're going to divide by 9 because it's the number that's in front of the x. And that gives me, I'm going to write it up here so you can see it. It gives me x is equal to 54 divided by 9 is 6. And the signs are different, so it's negative 6. Okay? So x is equal to negative 6. Once you're done with that, what am I going to do? Boom, go plug it into one of the original 2 equations that I've got. Does it matter which one? Nope, it doesn't matter. Again, what do I like to do? Small numbers and no negatives if possible. So I'm going to plug it into this bottom equation with the 3's and the 6's because there's no negatives, okay? So that's what I'm fixing to do. So I have 3 times x my x is negative 6, so I'm writing that in blue so you can see that is my substitution, plus 6y is equal to 6. Whoops, not negative 6. Now I just work it out, just like I've been doing. So when I do that, I get negative 18, because multiplication, plus 6y equals 6. Then I have to get my 18 over here to the other side by doing the opposite, which is addition. So I'm going to add 18. And that's going to give me something. 6y is equal to 6 plus 18, which is 24. And I'm going to go ahead and write this way up here at the top so you can see that. So I have 6y is equal to 24. Now to get my final answer, what do? Division. Divide by 6. And I get y is equal to 24 divided by 6 is 4. And it's all positive. Yay! Okay, so my ordered pair would be negative 6. I'll write it right here in the middle of everything. And positive 4. So that is my ordered pair, okay? This is what they consider the harder of the elimination or the addition method, because you have to multiply not just one equation, but both equations by a number, and one of those numbers needs to be negative, okay? Doesn't always happen that way, but sometimes this is what you're dealt with, so you have to be able to handle it, okay? I'll see you back in a minute for some more solving systems.